This is the story of how great science and a broken heart can sometimes go hand in hand. Lord Kelvin, one of the few scientists with name recognition, go out and ask the general public to name some scientists and they'd struggle. Who would they come up with? Newton, Faraday, Einstein for sure, Stephen Hawking, and possibly Lord Kelvin. And rightly so. Kelvin was one of the founders of the field of thermodynamics. It's thanks to him in part that we have a handle on concepts like energy, entropy, and temperature. But I want to talk about a particularly intense period in Kelvin's life. It's the early 1850s and he's still in his late 20s, although he has already been made professor at Glasgow University. But it's a time when tragic loss and rejection dominate his personal life. And it's also a time when he plays a crucial role in introducing a new idea to physics. And that idea is irreversibility. The fact that certain things, when done, cannot be undone. This was a new concept in physics. Newton's laws, for instance, are completely reversible in time. They make no distinction between the future and the past. Physics, in that sense, was divorced from the real world of death and decay, and Kelvin brought the two together. Irretrievable loss is as much a part of physics as it is a part of everything else. Think of a train going down the track. The mechanical energy lost through friction is gone forever. You can't get it back. Or think of an object like an iron bar, which is hot at one end and cold at the other. The heat will dissipate until it's the same temperature everywhere. That process will never go backwards. To Kelvin, this isn't just a minor inconvenience which happens on the periphery. It's a guiding principle for the cosmos. He points out that it means that the Earth will one day be uninhabitable, that the sun's energy will be depleted and it won't be restored. From here comes the notion of the heat death of the universe. The idea that one day all activity in the cosmos will cease. The great swirlings of stars and galaxies will unwind, all their energy will be depleted, and everything will be the same everywhere. There will be no meaningful activity, and time itself will stop. So what's going on in Kelvin's life when he introduces tragedy on a cosmic scale to physics? Well, he's head over heels in love with a young woman named Sabina Smith. He proposes marriage, she turns him down, and he's heartbroken. He writes to her saying, "Dearest Sabina, I cannot express to you how dreadfully I have been grieved by your letter and how ill prepared to receive it I was." A few months later, he proposes again, and she turns him down again. This time, he writes to her sister saying, he feels a bitter, bitter grief, far more than I felt prepared for. A year later, he makes one final attempt to marry her, and this time, when she says no, he gives up. Sabina came from an incredibly rich family. They owned a vast estate in an area called Jordan Hill to the west of Glasgow. It was so big that in the 20th century, when the city council acquired the land, they built both a teacher training college and a school there. But why did Sabina reject Kelvin? He was an eligible fellow. At the time, a friend of his wrote to him from Cambridge saying, "All the prudent mamas in Glasgow will be asking you to tea, but take care." And as far as we know, Sabina was quite keen on him too. Now, the villain of the piece appears to be her brother Archibald, who did not approve of the marriage. But it's not clear why. Archibald and Kelvin knew each other from Cambridge and seemed to get along. Was it because Kelvin at that stage was just a lowly academic and the Smiths were landed gentry? Who knows? It's a mystery. Where's Jane Austen when you need her? Picture Kelvin's world at this time. He lives in Glasgow, a city of extremes. On the one hand, there's incredibly wealthy families like the Smiths, but just a few miles from where they live are some of the worst slums the world has ever seen. Compounding the horrendous living conditions there are the tens of thousands of recently arrived immigrants fleeing the horrors of the potato famine in Ireland. A visitor to the city described it as being full of emaciated redheads. And on top of that, there's epidemics. Typhus and cholera both ravage the city, and Kelvin's father and brother succumb in short order. Surely Kelvin was affected by what was happening in his life. Scientists are like everybody else. The world they live in affects them. And I don't think it's a coincidence that Kelvin makes loss and irreversibility a part of physics when he's experiencing those very same things in his own life.